It's January 26th. This is Mr. Hansen's honors physical science class. And today we're going to make a real quick video about heating curves. We already talked about thermal energy and how much thermal energy an object has decides in part if it is a solid, liquid, or gas. We had our states of matter, and we had our phase changes, which are changes in one state to another. If something goes from a solid to a liquid or a liquid to a gas, it needs to gain energy to do that, so thermal energy must be added. Vice versa, if it goes the opposite direction, from a gas to a liquid or a gas to a solid, or a liquid to a solid, it must lose energy or give it off. So your label for your notes, which should be done with this video, is heating curve, or the heating curve for water. This is a link off the internet. There's about 1,000 of these things out there. This shows the heating curve of water, which we know it melts at 0 degrees Celsius and it boils at 100 degrees Celsius. Well, here it actually tells you what form it's in. You can think of this as solid, liquid, and gas. Here they put ice, water, and gas. I should probably say water vapor. As the temperature increases, you can warm the ice up to its melting point right here. At its melting point, it will gain energy, but it will not change temperature until eventually it turns to a liquid. And as we know, as we add more heat going down the x-axis, you can warm up water. You can have cold and warm water. We get to the boiling point up here. And when we hit the boiling point, which for water, again, is 100 degrees Celsius, it's different for all materials. But in water, it's 100 degrees Celsius. At its boiling point, it will remain that as it boils. And if we're still adding energy, the water will evaporate to a gas. And again, we can add energy to that gas, get it to expand and rise. So we're showing the red line go across. As heat is added, it increases. We already discussed that. And it goes in the opposite direction as well. Now here is what we would call the heat of fusion, this segment right here. And the heat of fusion is defined as the amount of energy required to change a substance from a solid to a liquid. You need to have that in your notes. The amount of energy needed to change a substance from a solid to a liquid. Heat of fusion, right there. Up here we have the heat of vaporization. And that is the amount of energy required to change the liquid at its boiling point to a gas. That is the heat of vaporization. And here, because of the segment lengths, you can tell less energy is required for the heat of fusion than the heat of vaporization. Now we're looking at another heating curve. And I would ask you, is this water or is this another material? And the way that you would identify that is by the temperature at which it melts and boils. So if you line up the y-axis with its melting point and the y-axis with its boiling point, you find this material boils at 100 degrees Celsius and it melts at 0 degrees Celsius. So again, we are looking at the heating curve for water. The only reason I wanted to show this one was that here it's showing the particles up here. It's a little more entertaining this way and shows you what's truly happening. The solid, as it warms up, maybe the pieces vibrate a little more, but they're all uniform, they're all closely packed together. Then as it's melting, you can see there is some liquid here. And there's some solid, you can think of that as an ice cube and some water melting. Again, heat of fusion. over here. Now it's all liquid, they're all moving. And as we add energy, I wish it would show as you go over here, they're moving a little more and a little more. But it is a liquid, they're moving around. When we get here to the heat of vaporization, now you have boiling. Do you have steam above water on a stove? You would. Some of it is boiling, and if you leave that pot on the stove boiling long enough, eventually you're not going to have any water. And it'll all be this. All right, that concludes the notes for today.